Welcome to episode 71 of George's Random Astronomical Object. Every episode, I run a random number generator to select random astronomical coordinates in the sky, and I then search for an astronomical object near those coordinates and talk about what makes the object so interesting to astronomers. This episode will also be featured on the 365 Days of Astronomy podcast, which you can subscribe to if you need astronomy content in the same way that you need your daily serving of fruits and vegetables. So I will now run the random number generator. The coordinates from the generator for this episode are 12 hours, 21 minutes, 54.9 seconds right ascension, and plus 4 degrees, 28 minutes, 26 seconds declination. These coordinates point to Messier 61, also known as M61. I just discussed a Messier object back in episode 67, so I am a bit surprised that the random number generator has given me the coordinates for another Messier object so soon. This one is actually a nice-looking face-on spiral galaxy. The galaxy is located not only in the constellation of Virgo, but also within the Virgo cluster, which is an enormous but amorphous cluster of over 1,000 galaxies located at a distance of 53.8 million light-years or 16.5 megaparsecs from Earth. Several other galaxies in the Virgo cluster are also Messier objects, and I could get sidetracked talking about them, so I'll stay focused on M61. M61 was simultaneously discovered by the Italian astronomer Barnabas Oriani and the French astronomer Charles Messier in May 1779. Both astronomers had been looking for a comet called the Comet of 1779, and while Oriani instantly recognized that M61 was not the comet, Messier thought it was. After watching it for several nights, Messier discovered that it wasn't moving like a comet should, which really annoyed him, so he placed it in his list of fuzzy things that aren't really comets and aren't really interesting to anyone. Today, that list is known as the Messier catalog, and it lists star clusters, nebulae, and galaxies that are much more interesting than any comet that Charles Messier ever discovered. The galaxy M61 is classified as a barred spiral galaxy, which means that it has a bar-like structure of stars running through its center. In fact, M61 has been a good place for astronomers to look if they want to understand bars in spiral galaxies. Bars form through gravitational instabilities in spiral galaxies' disks. Once they form, they end up exerting strong gravitational forces on the interstellar gas within these galaxies, funneling gas clouds inwards to the centers of the galaxies. Pushing a lot of interstellar gas into a small place will cause the gas clouds to collapse and form lots of stars. All of this has been seen happening in M61, and people have been particularly interested in the enhanced star formation in the galaxy's center. What's actually cool about the inner region of the bar is that the stars and gas have formed a miniature spiral pattern, and if you took a picture of just the center, you would think that it's a completely different spiral galaxy. However, in overexposed photos, these types of inner structures tend to look like bulges when they actually aren't, so they're called pseudobulges. Having said all of this, neither the extra star formation nor the miniature spiral pattern are what I personally think are the most interesting things about M61. Instead, what I found interesting was that the very nucleus of the galaxy contains a supermassive black hole. The measurements of the mass of this black hole are not that good, but it's estimated to be somewhere around 5 million times the mass of the Sun. Supermassive black holes are actually quite common at the centers of galaxies, and they form the cores of what are called active galactic nuclei. These black holes are often surrounded by thick disks of interstellar gas falling inwards. While the black holes themselves don't radiate light, The gas in these gas disks ends up being gravitationally compressed and getting really hot, and because of this, the gas radiates huge amounts of energy across the electromagnetic spectrum. Additionally, a lot of the gas gets so hot that, instead of falling into the black hole, the gas expands and blows away, forming jets of gas above the poles of the black hole, moving at close to the speed of light. These jets of gas can travel thousands of light years and produce huge amounts of X-ray and radio wave emission. These types of active galactic nuclei are truly exciting objects to look at, and the black hole in M61 is absolutely nothing like this. Instead, the black hole in M61 is just kind of sitting there, and doing nothing except exerting some gravitational forces. A little bit of really thin interstellar gas might be falling into the black hole, but it's not that much, and it doesn't produce much radiation while it falls inwards. It's kind of like the supermassive black hole didn't get its morning coffee, so instead of doing something exciting with its day, it's going to stay at home in its onesie and binge-watch Downton Abbey. The reason why the black hole hasn't gotten its morning coffee, or in other words, the reason why huge amounts of interstellar gas are not falling into the black hole and producing large amounts of electromagnetic radiation, seems to be because no gas actually gets anywhere near the black hole. As I stated earlier, the bar in this galaxy is pushing the interstellar gas towards the galaxy's center, but that gas gets used up by star-forming regions surrounding the center of the galaxy, and the young stars that form in these regions produce much more electromagnetic radiation than the area immediately around the black hole itself. The black hole itself ends up being starved of any interstellar gas. So while the black hole is moping about its lack of caffeine, its neighbors are consuming energy drinks with unnatural colors and partying very, very loudly. M61 is too faint to see with the naked eye, but it should be easy to see with a medium or large amateur telescope. The Virgo cluster is located between the constellation Virgo and the constellation Coma Berenices to the north, and M61 lies at the south end of the cluster, more towards the constellation Virgo. In a 20cm or 8-inch telescope, the galaxy will look like a fuzzy disk with a bright center, which, as you may recall, is a pseudobulge and not a real bulge. A 30cm or 12-inch telescope or larger will actually reveal the spiral arms. Be sure to drink something with caffeine so that you don't fall asleep like the black hole at the center of M61. The location on the Earth's surface corresponding to the position of M61 in the sky is in the middle of the Pacific Ocean. Unfortunately, I can't say much about this place. You won't find much of anything here. The website for this podcast is www.randomastronomicalobject.com. You can visit the website to download episodes of the show, read information about the astronomical objects, view images of those astronomical objects, look up additional reference information, and send me random feedback. You can also find this podcast on Facebook and on Twitter. The audio was recorded and edited by George Bendo. The music is Immersion by Sasha Endy at www.sasha-endy.de, and the sound effects are from the Freesounds Project at www.freesounds.org. Thanks for listening.